the whole layout would be there.
Okay, so now I'm going to talk more about database security features. There are security on many different levels in a database system. Obviously, you have the database server and you have all the data within it, and you have to control who can access what data. But you also need to be aware that you're passing data over the network, and we want to make sure no one can see what you're doing towards the database server, and you want to protect data when it's at rest on the storage media. If your database files are stolen, or so I'm going to look a little bit more deeply and show you what have we done with these different areas. So let's look a little bit. Just you probably know about this, but so I'll go quickly. Access control that shows who can access the database, what users can access what data, and what programs can manipulate the data. So let's see how we do this. In memory, you have three types of privileges. You have access privileges, which is basically privileges to allow you to either manipulate or read, select, insert, update, delete privileges. It gives you access either to a table or a view, and a view can then be part of a table, or it can be a join between different tables. You can actually do a lot of things with views once you get started on it. For example, show different views of the database at different times. The same view can show you different things depending on who is running. Then you have object privileges. That's, for example, we talked about a data bank in the last session, which is if you have table privilege on a data bank, you're allowed to create tables within that file. Or if you have a domain, do I allow other users to use my domain? If I have a sequence, who can use the sequence? If I've written a stored procedure, who has the right to execute this procedure? And then you have more powerful privileges, more DBA-like privileges for creating new users or creating schemas or taking backups, new objects in general. So this is pretty basic. I won't bore you with this too much. As we said with a view, so for example, here we have a table, and the table may be all the data, but the view is just showing the yellow parts here. So you can kind of restrict down to a single element, basically, who can see what. When you have a view on a single table, it can be updatable. So you can actually do an update on that view, and if the view has with check option, then you're not allowed to update so that the row or the values move outside the view. So you cannot take a row from the yellow view, update it so density. But if you have without check option, that's allowed, but then you won't see it again. Yeah, at least not through the view. When you access a view, you don't need to have any access, right, to the underlying table or tables. So this is also a good way of specifying who can do what. If you have an advanced view, for example, in the database, you have the whole information schema that shows all the objects in the database. And information, you have just one set of views for this, but depending on who is doing, for example, let's say I'm selecting from the information schema sequence table, I can only see sequences that I've created or that I have usage privilege on. But another user that selects from the same view sees whatever he's allowed to view. So the same view can show different things for different users. And you could also have a view that's based on the time of day or which weekday we're talking about. Or maybe the view just returns a snapshot of the last hour from a table, or so you can actually do some nifty things. There's something called an instead of trigger. For example, if you have a view that joins two tables together, out of the box, you cannot do an insert onto this view because the system doesn't really know how to handle this. But then you can write your own instead of trigger. So it gets all these values, and the trigger can do the two inserts or whatever it chooses to do. So that way you can make any view updatable. And so again, you can control. You can also allow the trigger code to test, okay, who is running now, and do specific tailoring. Or you could call an external procedure from the trigger that calls something from C# and find out some rules for something. So you can do really advanced things by kind of, because the trigger can block the operation from happening if it just doesn't like what it's. Okay, when you have a stored procedure, stored procedures are written in something called PSM, which stands for persistent stored modules. This is the standard SQL stored procedure language. And basically you have a language you have all the data types that you have for tables rather than data types in a typical programming language. So you have, for example, access to dates and timestamps and intervals. There are 13 different intervals in SQL. Day to hour, or day to minute, or minute to second, and so on. Or year, month interval, and so on. And with a stored procedure, you can actually you can access these data types immediately. I mean, you can do daytime arithmetic, for example, which would be difficult in more difficult in C or COBOL or whatever. When you create a procedure, the procedure can itself call other procedures, or it can do SQL statements. And the creator of the procedure must have privileges to call the other procedures. It must have privileges to do the insert or select or whatever the procedure is doing. So that's kind of checked when you do the create procedure. But when you run the procedure, let's say that I create a procedure and I give you execute access to it. When you call my procedure, it executes as in the context of me rather than you. So you don't need the privileges to the underlying objects. You just need execute on the procedure. So that again,
like a permission.
Yeah. So you have various levels here, and you can kind of figure out who gets to do what here. Okay. And it's the same thing if you have a procedure that you do a call with, or if you have a function that you use as part of a select, for example. It's the same thing, that the invoked function, it actually executes as the creator of the function rather than who's executing at the moment. So you need to be kind of aware of that this happens. In Mimer, we have something called program idents. So this is a special type of user that's actually an application program. Because a very common case is that, okay, we're developing this application and we're building in validation and we're building in rules on how to access the database, how to modify the database. So let's say you're now given, let's say you need to run this application. If we don't do anything, you would need to have access to all the objects that the application works with. For example, insert, update, and delete, and select privileges towards all the objects. But let's say now that you're running an interactive SQL utility, then you would have the same privileges. And through this, here you could do delete from table, semicolon, and everything in the table is gone. But if you're running the application, there's no function for deleting everything. So what we're doing in this case is that we're actually creating a user that's the application. So the application has these insert, update, delete privileges, and you have execute privilege on the application. That way, and this is actually used by almost all our customers because it's very, very practical and it eliminates a problem in the database world because everyone that's allowed to run all these applications that we have, they're also allowed to use interactive SQL utilities. That may not always be what we would like. And if you look at the details, the application does an SQL command, enter program name. So it kind of tells the database. And at that point, whoever is logged in has to have execute on the statement. Okay. So this is just a graphical depiction of this. So the program has the access rights and can do this. This user cannot do anything other than run the application. But if it's given select to something over there, maybe you can go into the interactive SQL utility and look at stuff. But maybe we don't want him to have delete access other than when he's running the program. Okay. If you have a large database, lots of users, it's usually a good idea to kind of think about how do I manage all of this? How do we spread the privileges around and kind of think, okay, I probably have a number of different types of users in this. Then you can create a group for each and you just let people be members of this group and they will get all the privileges that we're given to the group. And if you want to revoke something, it will revoke from everyone in the group. If someone has privileges from two different directions, kind of accumulated. So if you have insert from here and select from here, then you have both of these. Or if you have insert from two directions, you have insert. And if we revoke one of them, you still have insert. Yeah. So you kind of, there are instances of these privileges. And you have a built-in group, which is called public.
How do you prevent program B from masquerading as program A?
Because the enter statement has a password.
Ah,
So each user have a password for each to access each database.
Mm,
Like the user?
Yeah, it's to log in as the program, basically.
Oh, okay.
So first you connect to the database as the
Right.
user,
Mhm.
and then the program enters. And then when you're doing things in the database, everything that happens, all the statements that you do from there on are as if the program is running it, not the user out there. We can actually, if we want to peek, you have current user and session user. Or you can actually peek who's outside my enter if you need to know that.
So example, each Volvo have a user that can take a look in the database, right, for the same company, right, for the same table.
Say again.
So each user has access to the database, right, inside the table. So, but each user have different password or different way for the other one not to get into, right?
Yeah.
Oh, okay.
Yeah.
So it's not one person who control everything.
No.
Okay.
And it's also the case that the system administrator doesn't see the data.
Okay.
Unless it's only whoever creates an object has all the privileges, and he can grant it or she to someone else or to a group.
Oh, okay.
And to a system administrator if he wants to, but that doesn't happen automatically. The system administrator can back up and do things like that, but he cannot see the data.
Yeah, that makes
So
sense.
that's also a good. Okay. This is maybe not terribly important, but you can actually create a user that doesn't have a schema. And that type of user cannot do anything in the data, cannot create anything in the database. Because there's no way, he cannot even create a synonym or, so you can have kind of like users that you want to keep away a little bit. You can make sure that they're not filling up the database with 10,000 synonyms, for example, which anyone can do if you just have access to something. So, but without a schema, you can actually not do anything. Oh, you can select if you've been given privileges, but you cannot create anything yourself. Okay, so that was a little bit about access control and privilege. So let's go over now to the network encryption. We're using something called secure remote password protocol. This is, you actually don't send a password. You don't actually encrypt the password and send it either. This is a really nifty protocol in that way. So you're actually, the communication for each login, if you look at it, even though you're doing exactly the same login, you will have different stuff being passed over the network. And so this is, it's actually a really good protocol. You can look at this on Wikipedia, for example. It has a nice touch to it. If the database is stolen, the database doesn't happen to be encrypted, so you can actually see what's in the database. You can probably, if you're good at dumping things, you could probably find I could find the actual data with the encrypted passwords, but I cannot use that information to masquerade towards this database. So I cannot use this information to break the SRP protocol. So it has this protection. So even if the encrypted data that's stored in the server is stolen, that cannot be used for anything to break the system. That's not the case with some other protocols. So that's just a detail here. That with protection, with doing these things, you have to kind of consider all possible attack vectors. So this is pretty much what we had in the last session. Were you here?
No.
Okay. Let's just talk about this. So we have encryption between client and server. What happens is that you set a setting in the server. I want all my communication with all clients to be encrypted.
Like a certificate?
You don't need a certificate. You just set a flag saying encrypt.
Oh, okay.
And what happens is that you will get a unique session encryption key for each session.
Is that based on OpenSSL? the new open source?
No, it's actually based on the SRP algorithm.
Oh, it's a
It
very
happens to give you a unique key for each login that you make, which is perfect for the client server.
Every time that you send information, you create a new key, correct?
Yeah.
Well, you encryption, sorry.
Yeah. So even if someone breaks a specific encryption, it cannot be used for any other connection.
It's not like a specific, it's a specific key.
No.
Sorry, encryption.
Or if you steal a certificate, you cannot.
Yeah.
Then you would be able to actually break into this
Exactly.
database, but that doesn't happen here. And it's also a hassle with these with certificates. So we really want to do these things simple so that it's easy to use these things. Because if it's not easy to use, people will not use them.
Yeah.
It's really hard to combine ease of use and security. So we're really trying hard to make this simple.
Security and less complicated.
Yeah, exactly. Okay, authenticated encryption algorithms. So we can actually, the server can know that the package is coming from the server, and the response coming back, we can also authenticate that it's actually coming from, it's not someone masquerading as the server. We can guarantee in both directions that they are the one we trust. I mean, it's not protected. The unencrypted data is protected from eavesdropping. You can see the encrypted data. Tampering of the data is detected, and I'll show you some examples of how different types of tampering. And it uses hardware acceleration because we're using the AES GCM protocols, and they're actually what web servers use for HTTPS. So it means that it runs really, really fast. Okay, let's see if we can go into some details here. Okay, and then if someone records the conversation between the database and the client, he cannot later on replay this and try to emulate being the same user, because each login will be different. You cannot come with an old encryption, that will not work. You cannot come with the old encrypted set, even though the attacker may not know what went on, he cannot kind of masquerade with this later on and say, because that sequence will not be repeated because you have a new encryption key. And if you look at the packet stream, what happens is that each packet has a sequence number. This is the GCM part of the AES protocol. It has a sequence number. So when we're talking to the server, the client sends the first packet is 1, and then the response is 2, and the next packet coming down is 3, and then 4. So let's say that an attacker grabs a package and tries to insert it later on in the stream. That will not work because it will be the wrong sequence number. So you cannot kind of pull things out and even try to affect an ongoing conversation between the client. So because if that happens, then the connection is thrown out. And if the application is doing the same thing several times, you'll have different sequence numbers. So the packages will be different just because of that. So that also, you cannot see that the application is doing the same thing because you have repeated encrypted packages. So that doesn't happen either. Yeah. Maybe you don't really need to know about all these things. I'm just trying to show you what.
So good.
Yeah, especially in the cloud, this is of course very important that you have encrypted communication. When you're running in the cloud, you want to, however, minimize the communications. Usually more expensive than if you're running on a local area network or something. It depends on how much you pay. So, so typically applications work with ways of minimizing communication, doing bulk inserts or doing putting, for example, let's say we're doing 2 inserts and an update with some logic, then we put that into the procedure and make one call to the procedure. Or you can make an array of calls doing this 4 times, calling the procedure 4 times with one communication over. So there are lots of optimizations available for. Okay. We take a breath and dive into some more encryption then. Okay, so how do we make this simple for the user? We've really been thinking hard about this. You have the database server, we have the data down here. What's happening is that we have a database of some terabytes and it's encrypted with one algorithm. So we cannot do like we did in the client server interface, switch the encryption key. So we really need to protect the encryption key, make sure that we don't want the user to have to give a password or something every time you start a server to unlock the encryption key or something like that. We've actually looked at BitLocker as inspiration. I think they've done a great solution. What BitLocker does, I don't know if you're aware, this is used on Windows for protecting the hard drive. And BitLocker uses something called the TPM to store the encryption key. And the TPM is a little bit piece of hardware. It's quite similar to the trusted execution environment we talked about earlier. It's a bit piece of hardware that's not available to the OS. And it has a lot of encryption support and stuff. You have a recovery key for the database, but the recovery key is only the encryption. You take your recovery key and you can put this somewhere else on a USB stick or on another machine in the network. So you don't keep it together with the database. But your files are taken by someone, you don't want to give them the recovery key file. That's password protected, but still you can make this safe quite by having it separate. So as long as you don't move the file, you can just start and use the server as normal. But if you want to move it to another hardware or somewhere else, then you need the encryption file once again to unlock the database in that place to get the TPM on that machine aware of what we're doing.
I assume it uses a specific version of the TPM module.
Yeah, it's version 2 that has enough support for this. So you cannot do this on older hardware. No. Yeah, exactly. In our case, all database files are encrypted. Sometimes you say, okay, let's just encrypt this table. But what happens is, oh, we have transactions and a transaction log, and we have an audit trail, and we have temporary tables for sorting the data when we do a select. What happens is data from this table are in those files. So we decided to have this as an on-off switch for the entire database. Makes much more sense. You know that you're actually protected rather than having pieces here and there. If you look at the overhead, it's about 1% for an IO. So it's not too bad. And in our case, we're actually doing almost all write IOs in the background. So it's even less than 1%. So it really makes sense to. Yeah, I'm already ahead of me. Okay. Backups. So what happens here? Backups are also encrypted and with the same key. But if you want to use the backup on another machine, then you have to unlock it. But if you use the backup on the same actual hardware, then you're fine. Then you can, it works. But there are some tricky cases because it may be that customers taking a backup and then he starts encrypting his system. And then let's say we have a crash, disk crashes or something, and then we bring in the backup and that's non-encrypted. Yeah. You kind of have to keep, you have to be, you don't say, okay, now everything's encrypted and it has to be, because then you get into trouble in these situations. You have to be somewhat lenient, or what should I call it? So that was storage, encryption, and backups. Another deep breath. We'll continue with trusted execution environment. This is a cooperation we have with another company called Trustonic. They've been working in the mobile industry a lot. They're very integrated with ARM chips and something called a TEE on the ARM chips. And the TEE is, again, it's a separate little hardware module together with the ARM CPU. It's very, very similar to the TPM that we have on x86. It's not exactly the same. It has the same basic properties. It runs, the operating system is not aware of it. I mean, it has access to things. So for example, if you watch a movie, the movie is encrypted when it comes over the network, and to unlock the movie, those keys are highly desirable for anyone to, or for at least a hacker to get. So the movie is actually decrypted within the TE. And that way, you cannot get into the TE. I mean, you can probably open the hardware and try to get something out of it, but it will be very difficult. They're very hard to break. That's the point. So what happens is that we have a trusted execution environment, and we have applications that trust something called trusted applications that run within this environment. My last session, I gave an example for when you enter the PIN code on a mobile phone, that's done by a trusted application. It runs within the TE. So, or watching this movie also runs within the TE to be able to get at these encryption keys that we want to protect. But in some cases, we want to get things out of the TE. And I'll see if I have an example here. Yeah. So this is, here we have the trusted execution environment running over here within this little hardware module. And let's say that, okay, we have a GPS reader here. So we can actually take GPS positions of a vehicle that's out running. So for example, it could be a taxi service. We want to keep track of where everyone is and want to see how far they've gone during the day. And so we're actually creating these GPS positions within the trusted environment. And then we can, through the Mimer server, you can access things that we've allowed the system to see, obviously. But we're actually storing the data in here, is stored in the same formats in the Mimer database. So we actually have a client in here, and the trusted applications are using our client to store the data within the secure storage within the TE. But we can also get this data on this. So we create this GPS position, but then we can also use a signature on this GPS position. And that signature can be used to validate that the data has not been changed. So we can then take out the GPS position and the signature to the mean resting server. And let's see, I think I have, I'm not sure about the next. Yeah. Okay. So we can then have this in the car database. We can look at them and do our ordinary processing. We can maybe look at a map on the car display to see where were we and which way did we take this. Maybe this is a function for the taxi driver to look at his own rides for the day. And you can have ride applications, and typically on these platforms you have an Android for the car display. You may have something else for. And then we can take this data up into the cloud and accumulate the data from all the taxis. And once we get to the cloud, we still have these signatures. So we can still validate that this data has not been tampered with. So this is an example of kind of having a TE in one end can lead to data in the cloud that we can be completely sure that it's correct data. That's an example of this TE interaction with our data. So in this case, you're kind of taking the data from all the cars here, we're storing them in the cloud, and we can use database web apps to access the server, and the data can be validated. There are actually a number of other interesting cases with these trusted execution environments and looking at the data, especially during development, you can actually see what's in the TE. They've not had that luxury this far. They've had to write specific applications within the TE to do that. And now they can use their database front end, whatever, and look at this data. So it's very convenient when you start working with this. And then you maybe want to tighten the security down when you're finished. Yeah. So we're kind of looking at security from many different perspectives. You have the access controls within the database. You have the client server network protection. You have the database storage, and then you have kind of to consider, okay, so how do we interact with our environment and how can we secure data? Of course, you can take data from a client and put it all the way into the TE and store it there. And then that can be used by a trusted app later on, or it could be from another TE with a signature and so on. Okay. Here's just a little picture of what it looks like with the local communication with Beamer on OpenVMS. Then you have a shared memory here. When you map this shared memory, you're in executive mode. So it's a user-written service, system service that we've made. And so each client, even though we actually have a single large shared memory, each client only sees his part, his shared memory buffer to the server. He cannot map anything else within this. But the server sees the entire and can work directly towards this data, both for pulling data down and up. So security obviously comes in many facets in everything we do here. It's just a little example.
Theoretically, how would this work if, I mean, this is obviously on the same server.
Yeah.
Theoretically, if you had a widget that implemented shared memory between two separate physical boxes,
Mhm.
would you care? In other words, you take that shared memory segment, instead of being in local RAM, it's in the chip that is shared between the two servers.
if it's transparent, we wouldn't care, obviously.
Nice.
We would probably wouldn't even know that it was happening then.
Nice.
Yeah. Yeah. Yeah.
There's one feature with RDB that went away on integrity was row caching,
Okay.
because they need Galaxy memory in order to make row caching work between two separate systems.
Yeah, yeah. I see. Mhm. Huh. Okay. Okay.
Thank you.
Thank you.
I have a quick question, and then
Yeah.
I actually need to duck away. Different question, not related to security. How compatible is Mirror with other databases, specifically like Oracle Classic and MySQL? And the reason I ask is, several years ago, when I think it was MySQL and Microsoft SQL. Several years ago, when Oracle and Microsoft did something to drive up the cost of their licensing, what MySQL did was a marketing campaign that said, we are drop-in compatible with, I think it was MySQL, with, not MySQL, with Microsoft SQL.
Mhm.
They said, if you follow the Microsoft rules, you can change the server specification, connect to us, and you will run exactly the way you did with Microsoft.
Okay.
So
But
how-
then you're talking about that they're compatible on the network protocol.
No, end to end. I mean,
Okay.
I'm an application program,
Okay.
and right now I am making calls into the API to open the database, probably going through an ODBC connection.
Mhm.
But I'm making calls, to open the database, do this, and close. I don't care what's behind it. Right now, I'm saying I'm going to a Microsoft SQL engine.
Okay.
MySQL, when Microsoft drove up the cost of their licensing, did a marketing campaign that said, we are drop-in compatible.
Mhm.
And
Are you sure it was SQL Server? Because that's really hard. I don't think
I
they could
I
have.
may not have the products right,
Probably
but
another
the
data.
gist was vendor A drove up their pricing, and
Yeah, I see.
MySQL
Yeah.
said,
Mhm.
come to us because we are 1000% compatible with vendor A. I mean, all you really have to do is change the server specification on the client side, and you will run exactly the way you did with vendor A.
If someone claimed that, I would personally not believe it because.
Well, they also offered, because they were not only selling the software, but they offered a porting service, like they'll
Okay.
come in, they'll
Yeah.
analyze your SQL, they'll
Mhm.
tell you if you cut a corner and it wasn't 100% right.
Yeah.
So they
Yeah,
had stuff.
Yeah, but then you start to tweak these.
Yeah,
Because.
these are little tweaks, but
Yeah.
they said something like, if you do everything the way you're supposed to,
Mhm.
you can change the database spec and not even know that you're talking to MySQL now.
Okay.
How compatible is Mimer with something else like that?
I mean, we've always been very, very true to the SQL standard specification. But I mean, all databases have their own quirks, and sometimes they've even implemented standard SQL the wrong way.
Yeah.
And not following the specifications. So,
I
but
only
but
saw
in
this
general, I'd say it'd be quite easy to change. But you have things like error codes.
Yeah.
There are a lot of details here when you start to look into
Yeah.
this, both dialects of SQL.
Okay, well, let me ask the question a different way then. What other SQL platforms are you the most compatible with? Just your opinion, I'm not asking for a technical opinion.
I would say that, I mean, if you look at the different databases, I mean, you have Sybase and SQL Server in one corner.
Right,
And the way you work with them, especially historically,
yeah,
it's become better over the years, but the way they were using their stored procedure language and the flavor of that language is not compatible at all with what we have. But if you take other databases like DB2, they're implementing the same stored procedure language as we're doing.
Okay,
So it depends on
okay.
where you are, but I would say SQL Server and Sybase, they're over here.
Mhm.
And then you have this other group that we belong to that are fairly compatible, especially if you stick to standard SQL, then you're probably fine.
Wow, did you just jog some brain cells? I remember Oracle back on VAX, where you would do the SQL statements to define a database area. And then
Yeah,
Oracle and Microsoft made nice, and all of a sudden, I think it was Microsoft SQL 6.0 came out, which was really the code stream that they bought from Oracle. And if you dig into Microsoft SQL, it's still got a lot of Oracle in there. They have things called the master database. They have these things. They have other things which are
Yeah,
unique.
yeah.
And
Mhm.
and man, you just got a whole bunch of old brain.
Yeah, because it has to do with schemas. And
Yeah.
for example, RDB has their own RDB
Oh,
dollar
yeah,
schema. I mean, of course, you can create views that match that.
Right.
But it's not something that we have.
Oh,
out
yeah,
of the
that's
box.
right. Think about it. I always saw a marketing campaign like that once. I don't know how successful they were.
Yeah,
But they were going after people saying, come to us because we're cheaper, we'll guarantee like 1000% compatibility.
yeah. I wish I could say that, but
Okay,
it wouldn't be
no,
true.
I understand what you're
Yeah.
saying, I really do. Thank you. I have to run, but
Yeah.
thank you very much, this was excellent.
Anyone want my card?
Yes,
Okay. I don't have that many, so, but you.
I don't have any. Thank you. I will send
You
you
can
my
give me an
contact.
email.
Thank you very
Thank
much.
I will give you.
Me too. Very good time with age.
Yeah, so you will send me an email with some ideas about it.
Okay. Would you send me the presentation and some information that you will be important to review now and
Okay. Actually, I'm going to talk to you a bit more.
like.
Hold on. I see you. Thank you, Luis. Nice to meet you. Thank you. Don't be a man. Thank you.
Great.
We've dealt with you enough. Savant.
I'm sorry.
I work for Savant.
Oh, really?
So,
Oh, that's nice.
Yeah.
I didn't know that.
yeah, I'm the OpenVMS system administrator for
Oh,
Savant.
great.
So, yeah,
Uh-huh.
we've I think I even got support calls in the same time.
Yeah.
Yeah.
Mm.
Have you got a list of cloud solutions that you've tested?
Well, we've actually mainly gone on AWS.
AWS.
Yeah, because Microsoft tends to cut things out that you
Yeah,
cannot open up.
yeah.
You cannot open up 1360 or
That's
port
the
and that's
1360, the ODB.
with Azure and stuff. And
Yeah,
that's
yeah.
really
I
it's a
thought that's the
hassle, I
case.
think.
So you've not had it, and even running on an Azure VM,
We have done
but it's
experiments, but it's we'll talk later on.
connected.
Very good.
Okay. Yeah.
Yeah.
So you've not had it even running on Azure VMs, then it's all been locked down. You've not got access to
Yeah.
the 1360 ports.
No,
been
that's
closed.
right. That's right. But
Yeah.
we've definitely we did a little map application
Yeah,
where we had
yeah.
Androids running on a phone and it took data from Azure that had data in a Mimr database and it updated a map and you could see where it was slippery on the road,
Yes.
depending on other vehicles that were running the same thing.
Right. Okay. Yeah. So what about things like HP Green Lake? You looked at anything like that?
No.
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 So that's private cloud HPs and
Okay.
private cloud things.
Yeah.
NHSBT are looking to move towards this.
Yeah.
The AWS, the primary one. Okay. And what about hosting a container? or something like OCI? Have you heard of running on something like Kubernetes or?
Yes, we have.
Mhm.
I'm not the expert.
That's perfectly fine.
But
I'm not the database administrator.
Okay.
though.
So what are you?
I'm the OpenVMS administrator.
Oh, I see.
Yeah, so
Okay.
yeah,
Great.
so I am administrator. I'm just here for the OpenVMS stuff, but you know, this
Yeah.
was obviously something I would come to because
great.
we deal with mine all
Yeah,
the time.
yeah,
Yeah. Okay.
So nice to meet you.
Yes,
Yeah.
absolutely. And you.
Yeah.
Thank you very much.
Maybe we should come to Savant again.
I think we need to have a discussion in person.
Sometimes we met, on a more regular basis. I actually like the way VSI is doing this because
Yes.
he's saying, we're reaching out to all our customers and talking to them and seeing where will they be in a few years. I think we should do that.
Yeah.
I think it's a good idea.